Hello students, today I will continue from the next part of hydrogen chloride gas, that is hydrochloric acid, and I will start with the topic preparation of hydrochloric acid. As I told in my previous class, hydrogen chloride gas is highly soluble in water. So hydrochloric acid is prepared from hydrogen chloride gas by simply dissolving hydrogen chloride gas in water. Now you see, in this way hydrogen chloride gas is dissolved in water to produce the hydrochloric acid. So the hydrogen chloride gas is coming from here, it is prepared from the reaction vessel and it is coming directly through this pipe and getting dissolved in water. Now we can see that at the edge of the gas getting dissolved, here a funnel shaped arrangement is used. Funnel arrangement, this is known as funnel arrangement. Why funnel arrangement is used is a very important question. Why funnel arrangement? Because you see, we can see that as hydrogen chloride gas is highly soluble in water, as soon as the gas comes from here, a large amount of the gas gets dissolved in water and an air gap is being created. Now as this funnel shaped arrangement provides a large surface area, it minimizes the back suction and it avoids the water to come back to the reaction vessel. If the whole system was this narrow pipe, then the air gap would be large and the water would come back to the reaction medium where the hydrogen chloride gas is being prepared and it could be dangerous. So funnel arrangement is used to provide a large surface area, and number 2, to minimize back suction. So in exam also, if they are asking you in the question that why funnel arrangement is used to prepare hydrochloric acid, you have to give the reason, these 2 points, to provide large surface area and to minimize the back suction. So in this way, hydrochloric acid is being prepared from hydrogen chloride gas. Now generally by this method, we can prepare a very dilute hydrochloric acid and it is concentrated by distillation, and by distillation the acid can be concentrated only up to 22.2% HCl by weight and the other is by water at 110 degrees centigrade. Why? By boiling or distillation we can only get hydrochloric acid at 22.2% concentration at 110 degrees centigrade. Why? Because at this temperature and composition it produces constant boiling mixture. And what is this constant boiling mixture? This is known as azeotropic mixture. That is, at this composition and at this temperature, HCl starts boiling without any change in the composition. After reaching 22.2%, when the boiling is occurring, the composition is remaining same. So same amount of acid and water is going out of the vessel without changing the composition. So at 22.2% at 110 degrees centigrade, HCl produces a constant boiling mixture. Now if I come to the physical properties, everyone knows that acid is a very corrosive in nature. Similarly, concentrated hydrochloric acid is also very corrosive in nature and it causes blisters on our skin. It is acidic in nature and it is sour in taste, it is readily soluble in water and it is a volatile acid with a boiling point of 110 degrees centigrade. If I come to the chemical properties of hydrochloric acid, it will show all the properties that is generally shown by any acid, and the first reaction that any acid shows is when any acid reacts with a metal, it produces salt plus hydrogen. Similar for HCl, if we take dilute HCl and any metal, suppose Mg, the salt will be what? Magnesium chloride, MgCl2, and it produces hydrogen gas. Again, if it reacts with Na, sodium, it will be producing NaCl plus H2. So any any acid generally produces on reaction with metal salt plus hydrogen, and hydrochloric acid is no exception to that. So hydrochloric acid will react with any metal to produce salt plus hydrogen gas. Similarly, hydrochloric acid will be reacting with base to produce salt plus water. So HCl plus any base, suppose CaO, which will be producing CaCl2 plus H2O. Again, it will be reacting with CaOH whole 2 to produce CaCl2 plus H2O. Here 2 and here also 2. Okay. Now hydrochloric acid reacts with any carbonate or bicarbonate salt to produce salt, water and CO2 gas. So if HCl is treated with Na2CO3, it will be producing NaCl plus H2O plus CO2. So whenever you students will see that any acid is reacting with any carbonate, just produce the salt, water and CO2 gas and obviously balance it. If any acid reacts with bicarbonate, suppose magnesium bicarbonate, again it will be producing the salt magnesium chloride plus water plus CO2. So this is our basic reaction. After writing the reaction, obviously you have to balance the reaction. Next, if it is reacting with any sulfite or bisulfite, Na2SO3 if it is, then it will be producing the salt NaCl plus H2O plus SO2. In place of CO2, the gas in this case will be SO2. In place of CO2, the gas in this case will be SO2. For bisulfite also SO2. So if carbonate bicarbonate CO2, if sulfite bisulfite, it will be SO2. If HCl gas is reacted with sulfide, that is S2 minus, HCl plus, if anything of S2 minus, that is suppose Na2S, or if it is FeS, if HCl gas is reacted, it will be producing, hydrochloric acid is reacted, it will be producing salt plus H2S gas. Here also salt plus H2S gas. After that, you have to balance it. Okay. So the reaction is very common and similar for all the cases. Just you remember the product and you automatically can do the reaction. One exceptional reaction for hydrochloric acid is present if concentrated hydrochloric acid is treated with any oxidizing agent. It will be producing all the metallic chlorides, water and chlorine gas. And remember to write always in place of acid the term concentrated, otherwise it will become wrong because dilute acid will not give the reaction. So if concentrated HCl is reacted with any oxidizing agent, suppose KMNO4 is an oxidizing agent. How many metals are there? 2 metals are there, potassium and manganese. So 2 metallic chlorides will be produced, KCl and MnCl2, plus water and chlorine are the common product. So our product will be HCl plus KMNO4 producing KCl plus MnCl2 plus H2O plus Cl2. Now you have to balance the reaction. How to balance in class 9 also I have told you. First we have to generally balance the metal which is already balanced here. So as metals are balanced, we come with the part oxygen. So oxygen 4 means here I have to give here a 4. Here I have to give here a 4. Now if over hydrogen water I give a 4, the hydrogen changes to 8, so I have to give here a 8. Now total how many chlorines? 8. Already 3 and one odd number of chlorine is there, so I can never make it a even number if I don't multiply this odd number with a even number, which I cannot, because if I do it the metal will get changed. So automatically this way it will not happen, so I have to give here a 2, here a 2 and here a 2. Now the chlorine became even. If I give here a 2 before CoMnO4, the oxygen becomes, instead of 4, 8. So the oxygen here, it will be 8 and hydrogen will become 16. Now the chlorine is total 16, and here how many are there? 4 plus 2, 6, more 10 I need. That I can adjust here by giving here a 5. So this is our balanced equation. You can see in the book that many oxidizing agents reactions are given with concentrated hydrochloric acid, and in all the cases the products are always metallic chloride, water and chlorine gas. So whenever concentrated hydrochloric acid is treated with an oxidizing agent, it will be producing salt water Cl2, chlorine gas. Another reaction in this chapter, very important, is there. If dilute HCl gas is treated with sodium thiosulfate Na2S2O3, the product will be the salt NaCl plus H2O plus SO2, and apart from this as thiosulfate, there will be a precipitate of sulfur and the color is yellow. So apart from getting these three products for the sulfite salt, for thiosulfate one extra yellow precipitate of sulfur will be added in this equation. Okay, so this is also a very important reaction. Another one identification test of chloride ion is there. Whenever any chloride ion, not only HCl, if I take NaCl, if I take MgCl2, whatever, is treated with silver nitrate, we always get a white precipitate of silver chloride and HNO3. If the reaction was done with NaCl, same we would get. We would react with AgNO3 to get a white precipitate of AgCl plus NaNO3. So we can understand that here the common species is Cl to be present to give the reaction. So it is actually the detection of any chloride ion in any salt or in any acid. So if we treat it with AgNO3 solution, we will get a white precipitate of silver chloride, which is insoluble in dilute acids like nitric acid, but this white precipitate of silver chloride is soluble in ammonium hydroxide. If we dissolve silver chloride in ammonium hydroxide, we get a complex salt which is soluble in water, and hence we get a clear solution of diamine silver chloride, and hence the white precipitate, when lab we will do, we will be adding at first silver nitrate solution to any unknown species to detect the presence of chloride ion. If we get a white precipitate, after that to it we will add ammonium hydroxide. If the white precipitate gets dissolved, then we will become sure that the white precipitate was of silver chloride and there is a presence of chloride ion in the salt. Apart from this, one thing more is there, that is formation of aqua regia. Aqua regia is nothing but a 3 parts of concentrated HCl when mixed with 1 part of concentrated nitric acid, we get nitrosyl chloride NaCl plus H2O and nascent chlorine. Achha, what is this nascent chlorine? Nascent chlorine is a type of free radical. That means we always write chlorine gas as Cl2, that is Cl bond Cl. If we break this bond, we get Cl dot. And how we get it? You see, whenever a bond is prepared, it is prepared by mutual sharing of the electrons between the two chlorine atoms. So in a bond, there are actually 2 electrons, isn't it? And they already have more 6 each electrons with it, and they are forming a octet. Now to produce this, what happens? This 1 electron is taken by this chlorine and this 1 electron is taken by this chlorine. So the electron pair that is shared between the 2 chlorine atoms are mutually shared by the 2. 1 electron is taken back by the chlorine and another electron is taken back by another chlorine. And due to this, a chlorine radical is generated, which is known as nascent chlorine, which are very reactive species, and they are only formed during the course of any reaction and they doesn't have any independent existence. So aqua regia is a very strong acid, and even it is used to dissolve gold and platinum, the most inert metals in earth. So you will read the chapter carefully and you will go through the uses of the hydrochloric acid. I will be giving some homework related to this chapter. Please read carefully the distinguish, the balanced chemical reaction, the observation, and name the following. As you know the pattern of the board, I already discussed many times this type of questions in class 9. I hope all of you are aware of the pattern, like distinguish, like balanced equation, like observation, like name the following, like name the gas evolved. So practice this type of questions, and I will be giving some homework related to this chapter, hydrogen chloride gas and hydrochloric acid.